Hey everyone, so today we'll be talking about this counting tiling problem from CSES, and let's just quickly get into the solution part. Okay, let me share my screen. Okay, so there's a question. So basically we are given with n cross n grid, and we have to print the number of ways that we can fill that grid using 1 cross 2 or 2 cross 1 types. It's pretty simple, but we'll directly look into the most optimized approach here. So one very interesting thing to notice here is the constraints over there. So we can see n is only going to 10 and m is 1000. So this is pretty big value, but the point to be noticed here is there's one dimension that is only going to 10. Okay. I think we can make use of this because you should get an idea that if something is very less, it's like 2 to the power 10 will be only 1024. So we can use some sort of bit mask to store some information. What information? We'll just talk about that later. Okay. So the idea being, what I'm gonna do here is, so if you just flip the grid and it's sort of like m rows, that is maximum 1000, and n columns, that is only max 10 columns would be there, right? So if I'm currently at, let's say, 0th row, and I want to fill this particular row, right? If I can generate all the possible combination of, to fill that particular row using 1 into 2 or 2 cross 1 grid, 2 cross 1 tiles, and then store the information because see, 1 cross 2 or 2 cross 1 tiles will only have impact on the very next row. It cannot have impact on any subsequent rows because the max it can go is one level down. So if I can, if I can generate all the possible combination for the current row and store its impact on the very next row, okay, and then subsequently calculate all the possibilities for the next particular row based on the impact that was generated from the current row. Got it, right? So I think that should be it. We'll just, you know, explain further through code. Let's just quickly dive into the code. So I think the only input is NMM. So as I say, I'll be flipping the grid. It's like n rows and m columns. Rather, we'll be taking as n columns and m rows. Yeah. So recursive solution will be pretty simple. So I'll just have this information as I. Let's just make it global. Okay. So we'll need I, which is the current row that I'll be working on, and the current mask. So what is this mask denoting? So which cell of the current row are available to us or not? So 0 means it's available, 1 means it's not available. Okay. So if I, the base case being, if I've already reached last row, I mean, there is nothing to scan, then we just return mask equal to 0. Now, why mask equal to 0? Because how will we say that now the particular arrangement after filling all the grid is a valid combination when there is no overflow after we have filled the last particular row? So if there is no overflow, that means from last plus on the last plus one row, we'll get mask as 0, no overflow. Okay, right? Now we'll take a variable answer that will be denoting combination for the current row, and let's just define a separate function to generate all the combinations. It's called generate all combination, and this will basically fill my uh, combination vector. Okay. Now just iterate over all the combination. Uh, combinations. Combinations. Answer will nothing but answer plus the next iteration will be next row, and the mask will be nothing but combinations. I will simply return the answer. We have to take the mod as well. Yeah. Mod as well. Nothing but 29 plus 7. Cool. Pretty simple, right? And here we'll be printing 0 and 0. So current row doesn't have any tiles, so zero mask. Now, the only thing left here is to generate all the combinations. Let's create this function. What parameters we'll need? So we'll need on what particular column we are working. Let's just call it as I. Uh, we'll need the current mask based on which we'll generate the next possible set of masks, right? And this will be my next mask. We'll store this so that we can push this next mask to a particular container, which is nothing but a combination vector. I think that's it. That's all we need. Let's just quickly fill it here. So we'll start with zero column. Current mask will be nothing but a mask right here. Next mask will be zero currently because we haven't generated any possible subsets. Okay. Now the base case will be again when we have reached, it will be m, I think, since we have already flipped the grid. When I has reached n, it means we have scanned through all the columns. And then I will just need to push this next mask into the combinations, right? Combinations, push back. That's simply done. Now I'll create a copy mask, which will be nothing but current mask copy. Now, how will we generate the next possible set of combinations? So there will be three cases, right? So first case is simply if the particular column is already filled, it has been already impacted by the previous row, right? So it's not available to us, right? So we cannot do anything. We'll just simply ignore that and move forward. That means if the current column is already been, filled with some types, how will we know that? So this particular bit will be set in our current mask, copy mask, and one. So if this bit is already set, we cannot do anything. We'll just generate the combination for the next set of columns. Current mask will remain the same. Next mask will also have no impact because we are not even filling any sort of tiles there. Combinations, right? Now, what if this particular column was free? That means if not copy mask, and if this was not set, then we can say we can just put 2x1 tiles there. So if I'm putting 2x1 tiles there, I'll simply scan for the next set of column. Okay, current mask will remain same. Now next mask, since we have put 2x1 tile, so the next, the cell just below that will have an impact, right? Because they will all, the tiles will impact the next set of columns, right? Just below that, because we are putting this 2x1 tiles there. So next mask will have the impact, will have this as set bit. So this bit will be set for the next particular mask, and the combinations will be the combination, right? Now, so we have filled this 2x1 tiles. Now I need to fill this. There's one option that we can fill it 1x2 times, but for that, we need both the columns to be empty. Now we'll check for that. If not, copy mask. If both the I and I plus one cell are available to us, if both are available for this to be from the starting in case condition here that I plus one should be available to fine. Right? If both are available to us, then we can put 1x2 tiles there, in which case I will simply scan for the I plus twoth column since I in the I and I plus one column I put a time. And current mask will remain the same. Next mask will have no impact because we are not dealing with any set of column from the next mask. Next mask will remain same. The combination will be. So I think we are good here. Let's just try with this sample input. Let's see if we can make this. Okay. Seems like we have messed up something. We don't need here. Okay, 781, which is the expected. Let's just try to submit this. Let's see. I'm hoping for a time limit exceed. Yeah. So in order to optimize this, it's pretty simple. So we only have two varying parameters, that is the index and mass. So I'll just ask you, what is the maximum range that this I can take is? I is nothing but number of rows which can go till 1,000. So I'm just taking 1,001. And this can go to 10 only. So I'm just taking 11. And normal optimization will be nothing but I'm just memorizing it. Minus 1 to 1,000 mass. Here is the music. Let's just quickly submit the solution of that. Got it. Easy, yeah. Easy, right? Okay, we'll meet in the next video. Thank you for watching.